Hello everyone, I am Deepak Kumar from KIT University, Odisha. Today I will discuss the project on machine learning using Python. This project is assigned me by the Skyfi Lab on these online courses. Today we will discuss the regression learning by using Python. So first of all, we need to load all these library function from the Python libraries like pandas, numpy, matplotlib, sklearn matrix. We will discuss in future for that. So first we need to import all the libraries. Then the first step was data pre-processing. So the machine learning project is fully dedicated to Boston's house price prediction. So for that we need to load the Boston house dataset which have the uh, following attribute or informations like CRIM per capita crime rate by town, ZN, Indus, CHAS, NOSH, RM. These are the all these features that will affect the price prediction. So for that, uh, we we need to do the linear regression for the price prediction of the Boston House model. So here we'll do uh, first we'll import the data frame, Boston House data frame to pandas libraries. So for that we get 506 rows and 13 column dataset where we have one we have different features where we can see. Then if we want to see any one of the features like age, so we can see the age features. You can see any one of the features from CRIM to LSTAT. Then we'll assign our target variable. So for that assign, we assign the target variable. So target variable is fixed now. Then we can see the maximum and minimum of target. Then we'll do the concatenating features. Concatenate features is a simple thing, simple features like we need to add a target variable to the existing features. So we can see our target variable is added to the existing features. Then in the step two, actually I will tell you step one is data pre-processing. After that we will moving towards the step two, that is data visualization. So data visualization is a very fundamental details. Like we'll do the statistical analysis. Like we need to know what is count, mean, standard, minimum, maximum, all these parameter, statistical distribution parameter that can be done by describe function. So in that part, we'll see all these values. Then we'll do the correlations between the attribute and target. Before the linear regression process, we need to correlate between the attribute and the target. So after that correlation, we get this correlation with our target variable with the attribute. We see LSTAT is the maximum correlation with the target. So remember one thing here, uh, the function is having the maximum correlation will be taken as the variables for the regression process. So here you can see we have taken x and y. X is the LSTAT as it is the maximum correlation value. Then we have taken the target variable, that is y. Then after that we have done the uh, normalization process. So normalization process means the process is normalized to -1 to 1, like that. The value range should be in between that range. So in that normalization process we'll get the x and y value in normalized manner. Then we'll do the training and testing process. So here we need to split the dataset into training and testing. Like see here 0.2 means 20% of sample testing. Like I have uh, given the test size of 0.2, that means 20%. See, extrain from the X dataset, I have to extrain X test, Y train, Y test. So here I have executed the program, that is length of X train and X test, that is 404 and 102. That means out of 506 sample, 404 is for training and 102 for testing. These are the training testing process. Then we will proceed towards the cost function. Cost function is it is a very fundamental of any machine learning. So we need to find out the error. So there are several cost function is there. So we have selected the mean squared error as our cost function. So for that, I have defined error function. These are the error function formula. And typically, what is our hypothesis? We have taken the dataset in the planner. Like if it is a single weighted, the uh, hypothesis y is equal to mx plus c. If it is the multi-variant, means multi-weighted, so the slope will be in the plane manner, but it will be different. Then we have update functions like define update mxct learning rate grad. So this is the update value. The value will be update. Then we have the gradient descent function. Gradient descent function is the type of functions where we give the optimizations. Means our uh, error will be optimized, or it will be converged to the what is the our prediction. So this is the optimization process. So that we have taken the initial m rate, that is 0.9. In c is also 0. Learning rate is 0.001. Learning rate decides the how you will converge. Then iteration means number of steps will move towards our learning process, and error threshold. So for that, this program we run it and we will get CPU time is 3 microsecond. In total 4 microsecond. Wall time is 7.63 microsecond. While plotting the regression curve, we get X trend and Y trend in the scatter plot, and the uh, slope is the negative slope. So the predicted is very near to the range, scatter range. Then while plotting the error value, we'll getting the inverse hyperbolic. Like with respect to iteration, means if iteration will increase, the error value will decrease exponentially, negative exponentially. That indicates, means from 100 to 250, the error will constant. That means if you go for multiple iteration, one more iteration, means the error will be constant. So no need to go for that. So accordingly, we'll move as error is constant. Then uh, we'll do the animations, like how our error is converging. As the animation is here, so you can see how error from the initial point, the error is converging to the slope. Then we are calculating the mean squared error. Mean square error is 0.02 that are getting. Then this is the point where you'll see the what is our predicted and targeted value. So here particularly we'll see that this is the predicted and targeted output price, but that is in the normalized form. Okay, as we are already did it with the normalized point of view. So now we'll do one thing. We'll do means we will revert the normalization in inverse transform. Already in that process normalization we have done the transform process. So we'll do the inverse transform. So in the inverse transform process, we'll get our prediction. So here I'll say one thing. As we have the so these are the very important things like correlation. As Elstart we have taken, we can change this attribute to RM, and we'll see what is the consequences. RM. So we'll run and we'll see. So we run the uh, t- set in rm function. So we have taken that rm as the input value. So for that we can see there's a positive slope, and same thing, error is decreasing like this. These are these features for rm. Then we can see the slope is slightly converging, and the error also 0.02 mean square error. The error is increasing because while we'll moving like from L start to chas, if you increase the value, taking the input value, we can see the error will increase. Let's take as input as dish, and we'll run dish. So we'll run it, and we'll see how with increase in the correlations parameter we'll get see this is the regressions line curve, plotting regression curve, and this is the error versus iterations, and the animation you see how it is converging, and the error, see, error is 0.05, but the fast case the error is 0.02. It is increasing. That indicates that the choosing of the parameters from the correlations value is very important. That means if the correlations having the highest magnitude, that we should take, that is the optimum scaling that you should consider. Thank you.